Hi, this lesson's from page 500 in your student book, and the objective is students will be able to use properties of special right triangles to solve problems. The essential question is, list all of the properties that are true for 45, 45, 90 triangles, and then the properties that are true for a 30, 60, 90 triangle. So all right triangles that both have acute angles of 45 and 45, where both of their angles are 45, we automatically would say those triangles are similar to each other. And then because of, by definition of what a similar polygon is, we would say their sides can be set up to have a proportional ratio. So these two triangles are different sizes, but we can tell their angles. They're both 45, 45, 90 triangles, and so we would say they are similar to each other. All right, so because of that similar ratio, you can use a scale factor to find a missing length. So in your student work, if you see you're asked to find one length and you say, I don't know how to do that, remember that any similar polygon can have a ratio of sides to find the missing length. So we would say 3 is to 1 as x is to the square root of 2. And then when you just crisscross multiply, you would get x, so 1 times x, is 3 times the square root of 2. All right, another way of property would be to say if the lengths of a right triangle are equal. So look at the two sides, or the two legs of this right triangle are equal. So then that tells you right away that, well, we have a 90 degree, and because they are equal, then the two angles must be equal, and so they must both be 45 degrees. By definition, if it's a 90 degree angle, there are 90 degrees left in a 180 degree triangle. And because the sides are the same, the angles must be the same. So it must be a 45, 45. So the next thing is in a 45, 45, 90 triangle, the length of the hypotenuse is always the square root of 2 times the length of the leg. So in the previous slide we said the two legs of a 45, 45, 90 will always be the same because the angles are the same. And then if you did the work of figuring out Pythagorean theorem, this is just a property that's true for this special triangle. Then the hypotenuse is whatever the leg is times the square root of 2. A 30, 60, 90 triangle has a few interesting properties. So think of it right away as a ratio. Look at the ratio. 30, 60, 90 are all multiples of 30. So the ratio is the hypotenuse is always twice the length of the shortest leg, and you just have to memorize this. The shortest leg times 2 will give you the length of the hypotenuse. Or if you're given the hypotenuse and asked to find the shorter leg, just divide by 2. The longer leg is always the square root of 3 times the shorter leg. And then we would just say any 30, 60, 90 triangle would be similar to any other 30, 60, 90 triangle. So just like the beginning of our video, you could create a ratio, crisscross multiply, and then find that missing length because you would know they were similar to each other. All right, so in this situation, you've been told that it's a 30 and 90 degrees. So you'd automatically say, oh, I have 60 degrees left. This must be a 30, or I'm sorry, a 60. So 30, 60, 90, and you would say, oh, now what was that relationship between the sides? And I need to find the hypotenuse. And so you would recall, oh, I remember the hypotenuse is how much more than the shorter side? And remember, the shorter side will always be across from the smallest angle. And then recalling it, you would just say, oh, the hypotenuse in a 30, 60, 90 is always twice the shortest leg. And so then our missing hypotenuse length would be 8. Here they're given a 45, 45. And so you would ask yourself, what is the relationship between the sides of a 45, 45, 90? And you would say, well, 45, 45, the legs are always the same. And the hypotenuse is always the square root of 2 times one of the legs. So your answer would be 5 times the square root of 2 for x. And that is it. So great job. If you need to rewatch the video just to remember those properties, that's important. And then we'll do some examples together in class.